Hello students, good morning. Hello everybody. Welcome back to my class. This is Pradip Sir with another session of class 8 mathematics, and presently we are doing the chapter volume and surface area of solid. We have calculated, we have learned how to find the curved surface area, the total surface area, and the volume of a cylinder, and we have solved many more problems from there. So today I am going to show you, tell you how to solve some critical problems based on this topic. So here is the first one. It is given in the question that a rectangular vessel a rectangular vessel 22 centimeter by 16 cm, that is centimeter, by 14 centimeter, is full of water. If the total water is poured into an empty cylinder, empty cylindrical vessel of radius 8 centimeter, find the height of water in the cylinder. Okay. A rectangular vessel 22 centimeter into 16 centimeter into 14 centimeter is full of water. If the total water is poured into an empty cylindrical vessel of radius 8 centimeter, find the height of water in the cylinder. Now it is a case of transformation of one shape to another. It is given that the vessel is rectangular, that means it is a cuboid. Whose length, breadth and height are given. The length is given 22 centimeter, breadth is given 16 centimeter and height is given 14 centimeter. And it is full of water. Now this water is poured into a cylinder. It is poured into a cylindrical vessel whose height is not given. Height is not given, but the diameter is given. This diameter is given as 8 centimeter. Okay, so this is the situation. A cuboid is changed into cylinder. Now, during transformation of one shape to another, always remember that the volume remain constant. Okay, so here volume of water in the cuboid or this vessel, rectangular vessel, will be same as volume of water in the cylindrical tank. Okay, so first of all, let us find the volume of water in the cuboid. volume of water in the rectangular vessel equals to 22 multiplied with 16 multiplied with 14 centimeter cube. There is no need to multiply all these values. Keep it like that, because at the end of the this question, during the last step, you will find that the most of the things are being cancelled. So if you multiply this thing, it will take a lot of time, and during cancelling at the last step, you have to divide it and a lot of time will be wasted. So it is better, it is my advice, to keep the things as it is. Okay, now let suppose the length, breadth, height of the vessel is capital L, B, A and H. Length, this is the length of the rectangular vessel, capital L, B is the breadth and H is the height of the vessel. Okay, now let R be the radius and H be the height of cylinder. Here R equals to 8 centimeter, it is given. H is not given, we have to find H. Now volume of water in the cylinder. Volume of water in the cylinder equals to pi R square H equals to 22 upon 7. R is 8 into 8 into H. Okay, so this is also centimeter cube. Now, as I have told you that during transformation of shape, the volume remain constant. So here the volume of water in the rectangular vessel, that is 22 multiplied with 16 multiplied with 14 centimeter cube, is same as the volume of water in the cylinder, that is 22 upon 7 multiplied with 8 into 8 multiplied with H. So according to the question, we can write 22 upon 7 into 8 into 8 into H is equals to 22 multiplied with 16 multiplied with 14, which implies H equals to 22 upon 16 into 14 into 7. This 7 will be multiplied here in the right hand side, and the 22 will come in the denominator along with 8 into 8. Okay, now let us calculate. These 22 are cancelled. 8 cut 16 is 2, 2 cuts 8 is 4, 2 cuts 4 is 2, 2 cuts 7, 14 is 7. So the height is 49 upon 2 centimeter. Okay, or we can say that the height is 24.5 centimeter. So hope you have understood. This was very important question, but still it is easy. Okay, you can do it. So in transformation of shapes, always remember that two things are very important. Always remember that volume will be constant in both the cases. Whatever you are making, that is changing from one shape to another, in both the cases the volume remains constant. This is the first thing. The second thing, during the calculation, don't go for calculating from the very first step. Okay, keep the things as it is and keep it for the last step. There you will find in the last step most of the things are being cancelled and your calculation will become very easy. Okay, so understood. Now let us do one more. Very important sum. This sum is also bit critical and important too. The question is a piece of ductile metal, a piece of ductile metal a piece of ductile metal is in the form of cylinder, is in the form of cylinder of diameter 1 centimeter and height 11 centimeter or length 11 centimeter. It is drawn into wire of radius 1 millimeter. Radius 1 millimeter. Find the length of the wire. Find the length of the wire. A piece of ductile metal is in the form of a cylinder of diameter 1 centimeter and length 11 centimeter. Here the height of the cylinder is considered as the length of the cylinder, and that is equals to 11 centimeter. It is drawn into wire, it is melted and drawn into wire of radius 1 millimeter. We have to find the length of the. So this is the situation. The ductile metal is in the form of a cylinder whose diameter is 1 centimeter. The whole diameter is 1 centimeter. Therefore, radius capital R. I am taking the radius of the metal as capital R, and in case of wire, the radius I shall take as small r. So here radius r is equals to 1 upon 2 centimeter, because diameter is 1 centimeter. So radius will be 1 upon 2 centimeter, and this is the length. Length I am taking as capital H. H is given as 11 centimeter. Okay. So this is the case of the ductile metal, which is in the form of the cylinder. Now this metal will be melted and it will be drawn into a thin wire whose length I am taking as small h is not given, but the diameter is given. This diameter is 1 millimeter. Now if diameter of the wire is 1 millimeter, so we have to convert this diameter into radius. That will be 1 upon 2 millimeter. Now why we have to convert this unit millimeter into centimeter, because here the height and radius, that is the length and radius of the metal, is given in terms of centimeter. So here, since it is given in terms of millimeter, it should be changed in terms of centimeter. So small r is 1 upon 2 millimeter, and that is equals to 1 upon 20 centimeter, because 1 millimeter is 1 upon 10 centimeter. 1 centimeter equals to 10 millimeter. So this half millimeter, 1 upon 2 millimeter is divided by 10, that makes 1 upon 20 centimeter. Understood? Now for the ductile metal, which is in the form of cylinder, so radius is 1 upon 2 centimeter, diameter is 1, radius is 1 upon 2 centimeter, and length is 11 centimeter. Therefore volume equals to pi capital R square capital H. Now keep the value of pi as it is. So don't put the value of pi, because in case of cylinder we are getting pi, and wire is also a cylinder, so there also we will get the pi. These two pi will be cancelled later on, because there is a case of transformation of shape. Though one thing is melted to form another thing, but in both the cases the shape is same. Here it is cylinder and the wire is also in the form of cylinder. So when we will calculate, this pi will be cancelled from both sides. That is why I am not putting the value of pi. It will remain as it is. Only I shall put the value of radius, that is 1 upon 2 multiplied with 1 upon 2, it is square, and height is 11. So that will be 11 pi upon 4 centimeter cube. Okay, this is the volume of the ductile metal. Now for the wire, radius is 1 upon 20 centimeter and length we don't know, it will remain as it is. Okay, we have to calculate the length of the wire. Now volume equals to pi small r square h. Pi will remain pi. R is 1 upon 20 multiplied with 1 upon 20, as it is square here, r square, and h is unknown. So it will be pi h upon 400 centimeter cube. Now as I have told you that during transformation of shape the volume remain constant. So here according to the question, pi h upon 400 is equals to 11 pi upon 4. So h is equals to 11 pi multiplied with 400. This 400 will become numerator in the right hand side, and it is divided by 4 divided by pi. This pi will come down in the denominator. So pi is cancelled, 4 and 400 will be cancelled, that is 100. So here h is equals to 1100 centimeter, or we can say h is equals to 11 meter. Okay, therefore the length of the wire is 11 meter. Understood? So it was really very important sum. As you can see from this whole process, first we have to find the volume of the ductile metal whose height and radius are given. Then we have to find the volume of the wire whose radius is given but height is not given. And then one shape is changing into another, so the volume remain constant. Therefore volume of wire is equals to volume of the cylindrical metal. From there we got the value of the length of the wire. Actually here small h is the length of the wire, so that is equals to 11 meter. Hope you have understood the sum. So there are so many sums of this type where one shape is converted into wire. That means one shape like cube or cuboid or cylinder, it is converted into wire which is in the shape of cylinder. So there are so many important sums are there. Hope you now can solve all those problems related to this type. Understood? So let us conclude the class today. We'll meet in the next class. There I will solve some more problems related to this topic. Okay, so till then, goodbye and have a nice day.